Hi, good morning. This is our first partial project video, and we are Cristina Ramirez, Álvaro Garcia, and Ite Gutierrez. The problem we have to resolve is about the population growth, and this is the problem. The population of the world was 5.7 billion in 1995, and the observed relative growth rate was 2% per year. Find a function that models the population after T years. By what year will the population have doubled? What will be the population in 2015? Sketch a graph of the world population in billions versus time.
We have to write down all the data that you have, then the introduction to exponential functions. After that, we apply the exponential function to our problem. Then we get the function that models the population. After that, we have to graph that function on GeoGebra. Then for the we base on the graph that the point 11.4 because this is the double of 5.7. There's also the answer for C ubicated on the graph.
Well, we are going to start to solve the problem, and the first one says that we have to find a function that models the population after T years. So we have here the exponential function general that is equal to f equal to 2x, but we found that there's a formula for population growth on Earth that is n of t is equal to no exponential constant elevated to r plus t, where no is equal to the starting population, r is equal to the growth rate, and n of t is the future population. Well, here is our data that it says that 5.7 is equal to the starting population in 1995, and the 2% is equal to the growth rate per year. So this is the solution. If f of x is equal to 2x, then n of t is equal to no e over r of plus t. And here we have a solution that says that n of t is equal to 5.7 e elevated 0.02 plus t. Well, the second question says that by what year will the population have doubled? Well, if we know that 5.7 is the starting population, so we have to multiply for 2 to know the double, and then we have to localize this point in the graph. Well, here is 11.4 billion, that is the double of 5.7, and here's the line. And on the graph, it says that after 3-4 years, the population will be double, and this is by the year 2029.
Well, in this graph, we can see that for the year 1995 and the year 2015 are 20 years of difference. Then we conclude in the graph that the population will be 8.5%. In this graph, we can see that on this point, it's the population that we will have according with the years. In this graph, we can see that we have to make the formula for the problem, and this is how the population will be increasing with the time.
Application real life. Other applications in the real life with the population growth are money, depreciation, and bacterial growth. According to the problem and its development, we can say that as the year passes, the relative growth rate increases 2% to what had already been applied. This means that the increase is constant. That is the general answer for the problem.